Next up is square roots. They're also called radicals. Again, we're not going that deep into it, but square roots come from, well, squares. Okay, and this is the symbol for square roots. It's the radical sign is what we would call that. You can just call it the square root symbol. Either way, you shouldn't have to type any in. But a square root is like saying, well, you got the side lengths of a square, right? And the unique thing about the side lengths of a square, those are s's, not fives. The unique thing about the side lengths of squares is that they're all the same. Now the area, to find the area of a square, what you're going to do is you're going to take side length times side length. And as much as you want me to write s times s on this one, I'm going to put s to the power of 2. And yes, some people are like, I just got to do it. I got to do a equals s times s. Whatever, all right? It's the same formula. So square roots are going backwards. It's like saying, hey, let me give you the area. You tell me the square root. I'm sorry, the side length of that square. Which, by the way, since it's s to the power of 2, it's really like asking, and should be in here somewhere. It's really like saying, what number multiplied by itself gives us the number in the square root? So like this 100 right here, it's like saying, what number times itself is 100? And if we have our multiplication tables down very well, then we would know that number is 10. So using the multiplication table, which we see here, if you look at the multiplication table, just right through this diagonal. Why am I highlighting this diagonal? It's because if you look at the factors that make up this diagonal, it's all the same number multiplied by itself, right? Like 1 times 1 is 1. 2 times 2 is 4, right there. 3 times 3 is 9, and so forth, right? Even like 9 times 9, there's 81 right there. See that? All these numbers are what we call perfect squares, and the factors are the square roots. So if I said, hey, find the square root of 16, I would just need to find 16 on this diagonal. There it is. And I see both factors here are 4. So 4 times itself is 16. Of course, I only want 1 4, right? Because this is the actual side length of that square. So I only need the 1 4. Same with 49. So let's go and find 49. I'll do this in purple, actually. There's 49. It's on that diagonal. And the two factors, they should match. They're both 7s. So the side length of that square would be 7. Now 169, it's not in this list. It's not in the diagonal, but it should be close. And it should be close because it's just a little bit above 144. A little bit, maybe that's relative, but that means that I would start trying it because we're not familiar with our multiplication tables beyond 12. So it may take some guess and test, but I would just go right up to 13 on this. I'd say, well, 13 times 13, what do I get? If it's 169, then I know this answer is 13, but let's find out. All right, so 3 times 3 is 9, 3 times 1 is 3. That's my 1's place value. Add the 10's place value. 1 times 3 is 3, 1 times 1 is 1. And yeah, well, I should have given myself more space, but that's 9. 3 plus 3 is 6. And 1 is 1. So that is 169. See that? So that means 13 times itself is 169. So the side length of this square would be 13.